Okay, so we have another, this one's a true Taylor polynomial because this time we're not being centered at 0, we're centered at x equals pi over 2 for the function sine of x. So we just got to find a bunch of derivatives, plug in pi over 2, and then use the Taylor polynomial formula. So we have f prime of x is the cosine of x, f prime prime of x is negative sine of x, the third derivative at x is negative cosine of x, the fourth derivative of x is the sine of x, and notice it says the fifth degree, so I'm going to have to go out to 5 derivatives. Cosine of x. I think this should be 6th. I'm going to make this the 6th. The 6th derivative of x is negative sine of x. So f prime of pi over 2, the cosine of pi over 2 is 0. F prime prime of pi over 2 is negative 1. The third derivative of pi over 2, that's going to be 0. The fourth derivative of pi over 2 is 1. The fifth derivative pi over 2 is 0. That's why it couldn't be the 5th degree, it had to be 6th degree because there's no 5th degree term. So that was a typo on my part. The 6th derivative at pi over 2 is negative 1. So again, we just use this formula up here. I need to know what f of pi over 2 is. So I need to know f of pi over 2. The sine of pi over 2 is 1. So I'm going to use p of 6, which just stands for a polynomial of 6th degree. So my first term is just 1. That's just the f of pi over 2, which is 1. My next derivative, my next term is the derivative, which is 0 over 1 factorial x minus pi over 2. Notice this term is just going to go to 0. I really didn't need to write it down. My second derivative is negative 1 over 2 factorial x minus pi over 2 squared. Notice that these two numbers are the same. It's centered at pi over 2. That's why I need the x minus pi over 2. My third term is going to go away, so that's going to be 0 over 3 factorial x minus pi over 2 cubed. My fourth term has a derivative of 1, which is 1 over 4 factorial x minus pi over 2 to the 4th. My 5th degree term is 0. I'm not going to write it out. My 6th degree term is negative 1 over 6 factorial x minus pi over 2 to the 6th. So I'm just going to make this look a little bit nicer. So I have p of 6 of x is just going to be 1. This term goes to 0. This is just minus 1 over 2 factorial x minus pi over 2 to the 2nd power. This one goes to 0. This is plus 1/4. 1 over 4 factorial x minus pi over 2 to the 4th. And then the 5th term went away, and the 6th term minus 1 over 6 factorial x minus pi over 2 to the 6th. So notice that every other term is negative. So I'm going to, this is the Taylor polynomial, the Taylor series, meaning I write out with the sigma. You typically start at n equals 0 and you go to infinity. Notice that it's I only have even powered terms here, so I'm going to have a 2n factorial, and then I'm always going to have an x minus the center, which is pi over 2 to the 2n. And notice that my first term is positive. So when I plug in 0, this just goes away. And so it's just positive 1. When I plug in 1, I'm going to get this negative 1 over 2 factorial, x minus 1. When I plug in 1, matches up with there. I plug in 2, I'll get those terms. So this is the Taylor series, and this is the Taylor polynomial for that function.